Welcome to Chapter 2, which has to do with organizing and visualizing variables. This chapter has to do with charts, line charts, bar charts, Pareto charts, those kind of things that you have seen many times in your life. How to organize the data and make it visually appealing rather than just presenting a spreadsheet with a bunch of numbers. How to summarize the types of variables, so collect them and put them into meaningful categories, and avoid some of the common mistakes. Certain bar charts are better for presenting certain types of information, and we'll go through that. So we're going to talk about, this is the organizing part, and we're going to organize and visualize in the same chapter. So you have the categories. You have the one category, two categories, contingency tables, summary tables, etc. We'll go through this in more detail as we move through the chapter. So in this particular case, you have a summary table, which shows you what percentage of people use which devices to watch movies or shows. This has certainly changed over the years. At one point, we didn't have tablets and smartphones and things along that line. In fact, the YouTube videos that I'm setting up, I can actually see what type of device you watched the recording on, whether you watched it on your phone, your tablet, or your laptop slash PC. So that's kind of interesting to see what types of devices are being used. So we need to look for patterns. Sometimes they're referred to as neural networks. But we're looking for patterns. We do this as human beings. We want to see a pattern in something so we can use it for predicting future sales or future behaviors. So in this particular case, you have a contingency table, which is just probabilities. So you can see that you have two columns, no errors and errors, and you have three rows from small, medium to large amounts of the sample size, all right? And with regards to the invoice amount. So the sample size is the number of observations. The size of the invoice, the dollar amounts, are broken into small, medium, and large, if I didn't make that more clear. But we want to see where the errors are occurring. And of course, as you're well aware, you can have a large number of items, and so you're going to have more errors. And if you have a smaller number of items, you should have fewer errors, but you would also need to turn that into a percentage or compare them. So having 20 errors out of 170, is that better or worse than 5 errors out of 65? So you convert it into errors, into the percentages, and you can see no errors, errors from all of it. So in this particular case, 42% of 42% have no errors, and they belong to small invoices, 25 to medium, and 16.25 to large. So in total, 83.75% of the invoices do not have errors, and the 16.25 do have errors. Now, amongst the errors, where would you look? This could be a quality issue. You're feeling there's too many errors. You're actually going to look at, why is there 10% of the medium invoices, they represent 10% of all of the errors, are medium. So that would be the first area that I look at for training. What I look at to see whether there's a training issue, to see if there's a procedural issue, on and on, things along that line. And the one I would actually leave to last, at least based on the percentage error, is the large invoices. So maybe you have different people doing the jobs, and maybe the more experienced people are doing the large invoices, so they've been there for 15, 20 years. So in this particular case, you also look at it as a percentage of, in this case, the row. So within the small errors, 89% have no errors, and just over 10% do. So you break it down by row. And you can see that you're going to take the no errors for, say, small. You're going to take the no errors and divide it by the total of that row rather than the total of all of the invoices. So you can see that they took 170 divided by 190, and then they would have taken, you can do it one of two ways. You can take the 20 divided by 190, or simply take 100% minus 89.47, because the row will total to be 100%. So it breaks it down in different ways. It gives you different information. In this particular case, you can see that the columns are the totals. So wherever you see the 100%, that tells you where the total is. So in this case, it's broken down by the fact that you have no errors, and 50.75% of the invoices that have no errors come from small invoices. 29.85 are medium and large. And you can also see, once again, it highlights that of the errors, over 60%, 61.54% of the errors are the medium ones. So it gives you only errors are mainly the medium ones. And then I would, again, if this is a quality issue, you would try to address that or find out why there are so many errors in the medium invoices. And it doesn't give you the answer, but it tells you there is a potential problem. So we're going to next move on to ordered arrays, frequency distributions, and cumulative distributions. So in this case, we have an ordered array. In other words, they're in numerical order, and they will be from smallest to largest between day students and night students. So this particular case has to do with their age. And it is understood that at all schools, all post-secondary schools, the day students tend to be a younger demographic than the evening students. One of the major reasons for that is a significant portion or a larger portion of the day students have full-time jobs and perhaps family obligations. They can't take classes during the day. It's very difficult for them to do that. Now, with things like online becoming more and more prevalent, where you can take the course at any time, just like you can this course, even though it's scheduled for a certain time, you don't have to be listening to this. You can on demand, as I said in the introduction. This is like Netflix. You can watch it. You can watch 3 minutes or 30 minutes and then turn it off or replay anything at any point that you want, which has great flexibility. Frequency distribution summarizes the table. And we're going to look at the number of classes or the groupings and the width of the class. Like, you've seen them all the time. 1 to 5, 6 to 10, 11 to 15. That would be the class width from 1 to 5. And then the number of classes would be, in this particular case, if we did letter grades, what were the Fs? What were the Ds? Ds are 50 to 59. Cs are 60 to 69, etc. All right. So in this particular case, one of the first things you need to do is put this into an ordered array. This is hard to read, hard to figure out, and hard to group. In these cases, they're in Fahrenheit. So in this particular case, you find the range. The largest number is 58. And the smallest number is 12. So there's a 46 number difference between the lowest or smallest number and the largest. And usually try to keep your group sizes between 5 and 15. You start getting too many, like if you had 32, it's confusing. If you only had 2, it's too gross. They call it information granularity in the IT world. And too much detail is bad, but not enough detail is also meaningless. So in this particular case, we can see that 46, if you were to divide that by tens, like groups of 10, you would get 4.6, which you'd round up to 5. So you're going to make the group sizes from 10. So you don't have to start at 12 because it'd kind of be 12 to 22, 23 to, okay, no. So what you do is, okay, 10 to 20, 20 to 30, 30 to 40, etc., as you can see. The midpoints are simply there's a mathematical way to do it. You take the smallest number in the class, which is a 10 for class 1, and the largest number, which is a 20, add them together and divide it by 2. And most of us should probably be able to determine the midpoint between 20 and 30 is 25. Now, it's not as easy if you had classes that are 36 to 44, but it's also then, because we use 10 so much, if you can try and keep them to 10s or 5s, it makes it much easier for people to understand. And if you had a class width from 10 to 15, the midpoint would be 12.5. And that would be the average or expected value. So then you're going to count the number that are in the 10s. So you count 12, 13, 17. So there's 3 of them. In the 20s, 21 to 27, 1, 2, 3, I get 6. In the 30s, I get 5. In the 40s, I also get 5. That would be the frequency, because if you look at the numbers, you've got a couple numbers that are duplicates, like the 24s are duplicates, the 27s are repeated or duplicates, but none of the other numbers are duplicates that I can see. So, but if you just broke it down like that, it would just be like basically a flat line. What you're trying to do is say, oh, okay, there's 4 in the 10s, there's 6 in the 20s. You're going to see that in a moment with the chart. So you look at it. Now, this actually makes much more sense than just looking at the ordered array. 3, 6, 5, 4, 2. So it goes up and then it goes down. And we're going to put this into a graph. So you also can put it into a frequency. So in other words, just like we did, we take the total, which is 20, and we divide 3 by 20 to get 15, 6 by 20 to get 30, etc. So they did the one from 50 to 60, and they had 2 of them. So 2 divided by 20 is 10%. And that is a proportion, is the decimal, and then you have the percentages. So the relative frequency is a proportion, and then, of course, the far right-hand column is a percentage. So a lot of people like to prefer to things as 20, so as percentages. So what you can say is 30% are between 20 and 30 years old. And the schools pay a great deal of attention to their demographics. What percentage come from directly out of high school? What percentage are adult learners? And depends on the school what they define, but sometimes an adult learner has to be somebody who's been out of school for 5 years or more, or sometimes it's 3. And you would look at things like gender. In like business, usually slightly more than half the students are female. Usually 50 to 55% has been my experience. And so, of course, the male population is the inverse of that, or the reciprocal of that. And of course, yes, these days we have to be sensitive to the fact that there may be a third category, which people prefer to have various names for. So there could actually be 3 categories, not just the 2 that were in the past. But you'd want to look at that. You'd also want to look at where they come from, like where are they from outside of Calgary? And I would imagine that most students from Mount Royal would live in Southwest. Most students at U of C would say live in Northwest. SAIT would be a bit of a combination. SAIT's a bit more central, and that would be from the east, northeast, and southeast, and some from northwest. But you would also tend to, you'd want to look at all kinds of demographics. What percentage of your students are where English is a second language? And just as a little aside for you, SAIT has the highest percentage of students who, when they leave the school, go home and do not speak English. that when they go to where they live, that they go and speak another language higher than Mount Royal or the USC. So there is a difference in your demographic. So then you get the cumulative frequency, which is like a year-to-date number. So you take the 15% and add it to the 30 to get 45. 45 plus 25 is 70. 70 plus 20 is 90. And then 90 plus 10 is 100. So that's the cumulative frequency. So what you would use that for is 70% of this data group is 40 or less. It also would identify that 30% is above 40. So you can either add the 20 and the 10 or go 100% minus 70. Either way, you get the same number. So it's, so it gives you different types of information and gets you, allows you to say, compare your customer base, what they look like. iPhone users, for example, tend to be younger than the demographics for the other major phone companies like Samsung. They also have a demographic where they use their phones more, especially for data. So that's a big part of what Apple would understand about the demographic. They're not trying to sell iPhones to the 50-year-olds. They're trying to sell them to the 20-year-olds. And they're also aware that when Bell or Rogers or whomever has a plan, they realize if they're dealing with somebody who's of a younger demographic, they're going to use their phone more often and they're going to use more data. So that's why you see plans now that have unlimited, truly unlimited data use, because people are using it for all kinds of things, playing Pokemon Go, listening to Spotify, downstreaming movies, especially as we move into the 5G world. It's going to be heavy demand on data. So you can see here's a visual, a graph, a bar chart. Now this is a horizontal bar chart for the different devices. A bar chart has gaps between the bars. They're not like touching each other. So they're social distancing. Okay. All right. So this is a horizontal. Most of the time, I don't know about you, but I find this, I get it, but I prefer it vertical. But that's up to the person doing the presenting. And you can see that the bar chart it says, it's a bar chart separated by gaps. All right. Now here's a pie chart. Pie charts, I want to point out, are usually used when you're dealing with 100%. Like what percentage of our expenses go to travel? What percentages go to food? They're very good for that type of thing. And it's again, a different visualization. It shows you the magnitude, the size. You can see the television sets are the area on the left and represent, not even just even looking at the number, but represent, you just looked it up. Even if I took the percentages away, yeah, television sets are about half. Laptops and desktops are the second largest group. And the tablets and the smartphone, you can tell, are pretty close to each other, which they are. But when you're presenting, especially for those of you in accounting, you would present a lot of information in the form of pie charts. You can do it in bar charts. When you would say, but when it's like, and they're all the same, they're all related. So, and again, this is a donut, which is kind of like the pie chart, but just gives you a little bit of a difference. And again, you get the same type of effect. You can see that the area on the left, is pretty much half of the donut. All right. Now, in this particular case, Pareto charts. Pareto charts are used very much as one of the 7 tools of quality, which you would take in your supply chain course. If you take LSCM 3403 or SCMT 300 or a course in quality, depending on what school you're going to. So you can see they have a very specific order. You can see in this case, in the percentages, which we calculated as the frequency. Then we have the percentage, and then we have the cumulative percentage, which is called an ogive, right? O-G-I-V-E. So ogive, ogive. So what we have here is a bar chart. You can see the percentages of the warped cable jammed, card unreadable, etc. And if you're looking at quality, you're asked to, okay, find out what the quality issues are. So you go out and you measure them, you get your data, and then you need to present it to management or other people on your team. You can see very easily that the two on the left, the warp card and the card unreadable, are by far and away the biggest. And so what are you going to focus your efforts on? Those two. And it's very important that you realize that a Pareto chart starts on the left and goes to the right. It's like a set of stairs that are going down. And so you start off with the most frequent problem on the left until you get to the far right, which is lack of funds in account, which is the least problematic or the least difficult or the least frequent error. You can also see the line with the little boxes, and you can see that this is the cumulative amounts. So you would add the warp cable and the card unreadable, and that would give you about 80%. So if you are told, okay, I'm giving you a month to improve the quality, and I want at least 80% of the errors to be dealt with. Well, I'm not going to work on ATM malfunctions or invalid amount requested. I'm going to focus on the two on the left, and I'm going to look at those. And those are going to be my focus to try and reduce, or maybe not eliminate, but try and reduce things along that line. So those are your priority issues. The other five, you get to them when you can. After you've, solved or tried to solve the two most frequent errors, then you would move on to some of the small errors like ATM out of cash, things along this line. So here's again a summary. All right. Histogram is a bar chart with gaps. Okay. Well, sorry, there are no gaps with a histogram. Sorry. All right. The class boundaries we talked about, the frequency, the relative frequency, and the percentage. And you can do it in percentage, which a lot of people prefer. And of course, as we're well aware, the height of the bar represents the frequency. So here's a histogram. And in this particular case, histograms are very often also presented to look like what is called a normal distribution, which we'll take in a course. This, if you put this histogram from the largest to the smallest, that would be a Pareto chart. So a Pareto chart sort of specialized version of a histogram or bar chart. And don't get too worried about the gaps, no gaps, and stuff along this line. It just depends on how you want to present the information. And in this particular case, if you're trying to make it feel like it's all continuous, this is what you would do. If you want to separate them like it was in the histogram, in the Pareto chart, then you want some separation so it's just easier. In this case, you can see there are continuous categories. But in the Pareto chart, they were not continuous, so it's a good idea to put gaps between them. And that visually, especially for those of you who are visual learners, that makes a lot of sense that they're separate from each other. But this is a continuum. Sorry, technical difficulties. Frequency polygon, you're going to see in a moment. Cumulative frequency polygon or ogive. So this is what you see, line chart. And this is simply a polygon. So fancy word for line chart. You see they tell us different things. And the meal costs. And you have the two different lines. Right. And for a 3-year return, this is again different ways of presenting the same information. This is an ogive. How do I know that? Because it totals to be 100. It's the cumulative frequency. So you can see where they separate, but they start off at the same point, and then they end at the same point. They will always end at 100%. But you can see very clearly in this case, the city center, or the center of city, is below the metro area. So whatever this is measuring, meal costs in this case, it's cheaper in a city center than it is in the metro area. So if you're eating, where would you want to eat? Center city. And again, here's sort of a different view of it with a different scale. And this is growth. Same kind of optics as the previous one, just different information. All right, scatter plots are used for trying to see trends and directionality of like what's going to happen next. So in this case, you can see with the scatter points where they start off on the left and then they go to the right, and this is volume per day. You would say that, you know, when the volume is 23, the cost is 125. So this would be relating volume to costs. Your x-axis is your independent variable. So the volume drives the cost. The costs don't drive the volume. Time series uses time. It's very common. I'm sure you've seen them. So in this case, you see you're looking for the number of franchises over time. You can see that the number of franchises from 2011 increased to 2017, and something happened in 2017 that now you're seeing a downward trend in the number of franchises. So if this is a business, you would like to see growth. Even schools want to see growth. They want to see larger enrollments. That is the mantra of business, but it also applies very much to even post-secondary. So if you see your enrollments going down, I know that with oil and gas having been very much devastated by the lower oil prices, the enrollments at certain schools have gone down. With the demographics changing, the number of students taking evening classes has gone down because there are fewer students to take them. There's a smaller population to take them because of the baby boomers and the echo generation and things along this line. The baby boomers are not going to school anymore. They're literally too old for that. And the echo generation, which was the baby boomers' kids, are now getting into an older age. So if the baby boomers are 60 to 80, somewhere in that range, their kids are now, say, 25 to 40, and a lot of their schooling has been done, or they're less likely to go to school when you're 35 than when you're 25. So in this particular case, it's also showing you some bad and good presentations. And in this particular case, you can see that on the left, it shows it in the numbers or frequency, and on the right, it shows you as a percentage. So you can see you get very different information, like SO is for sophomores. You can actually see that they had the highest percentage of A's. Whereas freshmen, because there tends to be more freshmen than there are sophomores, they had more A's. But as a relative number, sophomores did better than freshmen. And just think back to your own experience. Did you do better in even your second term or your second year than your first year? Because in the first year, so many things were new. Maybe you'd moved. Maybe you were just not used to the university way of doing things. And I know personally speaking, my second term, as it turned out, was the highest grade point average I had in all my in my undergrad. I had the highest marks. Again, the graph on the left and the graph on the right, like the numbers don't change very much. Like there's not a lot of differentiation. Whereas you see the numbers on the right, because you've changed the scale. See the scale on the left are from 0 to 200, the scale on the right from 0 to 50. So all that white space on the left is just meaningless, and it compresses the bars. On the right, you can see, you can feel for the difference that Q3 is much stronger than Q4 or even Q1. Again, in this particular case, monthly sales, these are actually fairly similar, as you can tell, but you shouldn't start a chart off at 36 is what it's trying to show. You can put this little squiggly line in, which means there's no data below 36. So that's why they look similar, but it gives you a better sense of scale, right? Graphing for the first 6 months of sales. All right. And sometimes there's a tendency to want to put in all this clutter, all right, and make it look really pretty, and so, simple is good, right? You just, if you're looking for the big picture type of things, you can see that much more easily on the right than the number on the left. Although the number on the left is more visually appealing. It's got the tree, it's got the grapes and all of that. But the one on the right is plain, simple, and easier to read. All right. So this is just a summary of what we've covered. I'm not going to spend a lot of time on this. The summary of the types of mix of variables, how to visualize them, etc. So I hope you enjoyed that. And that's the end of the chapter.